All right, let's continue on with number 8. We're asked to evaluate the following integral and indefinite integral. And what I see is there is a fraction on the denominator. Normally, if you have a numerator and denominator, usually your u is going to be your denominator. Let's see what happens if I do that. U can equal x squared plus 4x. And then if that's the case, du equals 2x plus 4 dx. But I don't have a 2x plus 4. I only have an x plus 2 dx. But I can notice that there is a factor of 2 that I can factor out. And if I divide that over to this side, I'm left with du over 2 equals x plus 2 dx, which is my numerator. So now I have everything I need to plug in. So du over 2 is x plus 2 dx. So that's 1/2 integral du. And then what's left? Only my denominator, 1 over u. So what is the antiderivative of 1 over u? It's going to be ln absolute value of u plus c. But remember that for a logarithm, this constant in front is an exponent. So this is actually ln square root u, absolute value, plus c. But remember that u was x squared plus 4x plus c. So we have a little bit of properties of exponents and that properties of logarithms in this one as well to simplify our answers. So whenever we have a constant in front of our logarithm, make it an exponent to simplify. Now number 9 is kind of a special case. It's a special case because we're going to have to do a procedure called a change of variable. Change of variable. And I'll show you what that means in a minute. So when I look at this problem, I have a radical. So probably what's inside of it can be my u to try to simplify this problem. So I'm going to let u equal x plus 1. And then that leaves du equal to dx, which is great. I have square root of u du. But what I'm left with that's stuck is this x squared. How do I change x squared to be in terms of u? And that's where this change of variable piece comes from. From this piece here, I can isolate x and say x equals u minus 1. So then that means that x squared is u minus 1 squared. So now I have changed this variable x to be in terms of u as well, beyond all the other extra u substitution we were solving. So now I can substitute in what I know. X squared is u minus 1 squared. And then this is square root of u du. So I need to simplify this. I'm going to FOIL this out. This becomes u squared minus 2u plus 1 times u to the 1/2 power du. So that becomes the antiderivative of u to the 5 over 2 power minus 2u to the 3 over 2 power plus u to the 1/2 power du. Now this is looking like something we can definitely take the antiderivative of. So let me go ahead and do this in a different color on the next step. So the antiderivative of u to the 5 over 2, adding 2 over 2, that becomes u to the 7 over 2. Dividing by 7 over 2, I have 2/7. And then minus 2u, 3 over 2 plus 2 over 2 is 5 over 2. I'm just going to go ahead showing dividing by 5 over 2 here. I'll simplify in the next step. And then we have a plus 1 over 2 plus 2 over 2 is u to the 3 over 2, divided by 3 over 2 plus c So let me simplify and plug in my u's here. So this is 2/7 x plus 1 to the 7/2. And this becomes minus 4/5 x plus 1 to the 5/2. I think I said x plus 1 here. I can't remember. And then plus 2/3 x plus 1 to the 3/2 plus c. So now we have this elaborate antiderivative that we could take the derivative of to check our answer. And now in our next video, we're going to see a second way we could have approached number 9.